Good morning, this is Dr. Turner for Integrated Math 1. Today we're going to be covering 5.4, which is solving equations involving variables. Specifically, the variables are going to be our exponent. There are other techniques to do this. Specifically, we'll talk about logarithms when we get to Integrated Math 2. For now, what our goal is to rewrite the base so that we have the same base on both sides, and once we do that, we can set the exponents equal to each other. So, as I always say, once you've done it a few times, it's pretty straightforward and hopefully it'll sink in, but we'll try to get through this this section pretty quick. So here we go. So with all of this, and we'll try to get rid of some of this here. There we go. Okay. Again, the goal is to rewrite it so that the base is the same. So if I had a problem, let's say 2 to the x equals 32. The goal is to rewrite the right side so that I have 2 to some power. Now, some people can do the math mentally. Some can't. That's fine. Typically, when you're doing this, you'll have access to a calculator. At the very least, since you're using your Chromebooks, you can use Desmos, remember, as a normal calculator as well. So you always have that option. So if I was to use my calculator, what I would do is I'd pull up my calculator or Desmos, and you're just doing 2 times, however many times it takes to get to 32 in this case. So 2 times 2, and you'll see that the answer will pop down there at the bottom. Times 2, times 2, times 2. So 32... it took 5 2s, 2 times itself 5 times. So therefore, I can rewrite the right-hand side of this equation as 2 to the 5th power. Once the bases are the same, based on our properties of equality, then we can set the exponents equal to each other. Therefore, this is x equals 5. Again, there's other ways to get there, logarithms, which we'll talk about in Integrated Math 2, or even just putting a box there and asking what goes in the box, just like when you first learn about variables in elementary and middle school. So as long as you get there, I'm fine with whatever technique you want to use. Do another example. Let's say 10 to the x equals 100. And again, if I need to, I can go back and use Desmos 10 times itself until I get to 100. That one, fairly easy, right? 100 is just 10 squared, and therefore x equals 2. So you have a few problems on your assignment that are like 1 and 2. Most students do okay with those. When fractions appear, that's when typically students get a little lost. So let's say I had something like 3 to the x equals 1 over 27, for instance. Okay. Well, the number on the right is smaller than the base that I'm trying to achieve. This is where you would need to use your negative exponent rule. If you need to, you can go back to, off the top of my head, I believe it's Unit 2. There's a video on rules of exponents if you need a refresher. But your negative exponent rule states that if you have a negative exponent, say a to the negative m, that is shorthand for having an exponent in the denominator. So this is the same as 1 over a to the m. So if you think of an exponent as repeated multiplication, a negative exponent is kind of like repeated division, right? You have multiplication, but it's in the denominator. You're dividing by that value x number of times. So our goal here on number 3 then would be first to change 27 to some power of 3 using Desmos or doing the mental math, but 3 times 3 times 3 would give me 27. Therefore, 27 is 3 cubed. But I can't just say x equals 3 here because I don't have the exact same base and it doesn't look the same on the left and right hand side. Now, using my negative exponent rule, I can rewrite this so that it's no longer a fraction. 1 over 3 cubed, according to the negative exponent rule, is the same as 3 to the negative 3rd power. Now we have the same base, and therefore my answer to this problem is x equals negative 3. Okay. Let's do one more that looks like that. Number 4, let's say 5 to the x equals 1 over 625. The smaller numbers like 100 I would expect you to be able to do the mental math for. If it's a larger number like 625, again, you're welcome to pull up Desmos and just do 5 until you get to 625. 5 times 5 times 5 times 5. Therefore, 625 is 5 to the 4th power. We need the bases to be exactly the same on both sides, so I'll use my negative exponent rule to rewrite that as 5 to the negative 4th power. And now that the bases are the same, my answer is x equals negative 4. So that makes up a good 70–80% of your assignment, either doing problems like 1 and 2 or doing problems like 3 and 4. Now notice here that all the answers that I got were integers: 5, 2, negative 3, negative 4. They were all whole numbers. It is possible to get a value that's not. It could be a fraction or a decimal, but for us, since we're just learning this concept, all of your answers will be integers. Now the other thing that can be thrown at you is where you have a base that's not a whole number. So for instance, if I had something like, let's say 1/2 to the x equals, say, 16. Okay. Well, here it's a little tricky because on the left-hand side I have a fraction, on the right-hand side I have a whole number. Well, how do I do that? So what we're going to do is we're going to try to rewrite 16 first as a power of 1/2. Now, if you notice number 3 and 4, when I had a fraction and a whole number, I ended up needing a negative exponent, right? That basically flipped the value. So here, I'm going to need a negative exponent as well to be able to go from 1/2 to 16. So 16 I can rewrite as a power of 2 first. Would be a good place to start. Again, using Desmos or a calculator. 16 ends up being 2 to the 4th power. Well, okay, I have 1/2, but on the right side I have 2. Well, what I can do is I can make the 2 a fraction by making it 2 over 1, putting a 1 in the denominator. Because remember, 1 to any power is just going to give me 1. Well, now it's almost the same, but on the right I have 2 over 1, and on the left I have 1/2. So then what I can do is use my negative exponent rules, and by using my negative exponent rules, that's essentially going to flip that fraction. If I do 1 over, and this is just scratch work here, but 1 over 2 over 1 to the 4th power, then I can rework this so that it is 1/2 to the negative 4th power. Therefore, x equals negative 4. Okay. You can always verify this using the calculator if you're uncertain. So the fraction ones are a little bit trickier, but let's say I wasn't sure if that was correct. I can do 1/2 using any calculator, and then raise that to the negative 4th power, which generates 16, which is what we wanted. Okay. So anytime you're dealing with a fraction here, you're going to end up with a negative exponent, whether that fraction is on the left-hand side, like a number 5, or on the right-hand side, like numbers 3 and 4. That's all for today, guys. If you have any questions, please reach out to me. Otherwise, have a good day, and I will talk to you soon.